Welcome back to Max with RP. In our earlier video, we had discussed about basic proportionality theorem, how to prove the theorem, and also how to solve problems based on the theorem. Today, we are going to discuss the converse of the theorem. So, first of all, what did basic proportionality theorem say? According to basic proportionality theorem, if a line is drawn parallel to one of the sides of a triangle, that is D is parallel to BC, then AD by DB is equal to AE by EC. Okay, this is what we proved in the earlier video. Now this result is called as the basic proportionality theorem. Okay, so DE is parallel to BC, then AD by BD is equal to AE by EC. Now two more results actually follows from this. Suppose I add 1. Then what will we get? AD by DB plus 1 is equal to AE by EC plus 1. Now this means AD plus DB by DB is equal to AE plus EC by EC. Now AD plus DB, you all know, this implies AB by DB. AD plus DB is nothing but AB. So AB by DB is equal to AE plus EC is AC. AC by EC. So this result follows from the basic proportionality theorem. So if AD by BD is equal to AE by EC, then AB by DB, AB by DB is equal to AC by CE. Okay. Now this is the, let us call this as result 2 and this is result 1. Now suppose I invert it and then add 1. Okay. If AD by DB equal to AE by EC, definitely DB by AD is equal to EC by AE. Now let us add 1 on both sides. So DB by AD plus 1 is equal to EC by AE plus 1. Which means DB plus AD. What is DB plus DB plus AD by AD is equal to EC plus AE by AE. Now this implies, what is DB plus AD? DB plus AD is nothing but AB. This implies AB by AD is equal to, what is EC plus AE? Nothing but AC is equal to AC by AE. We'll call it as result 3. So, on account of basic proportionality theorem, which says if a line is drawn parallel to one of the sides of the triangle, it divides the other two sides in the same ratio. So, AD by DB is equal to AE by AC. The proof of this is already done in the earlier video. Now, what is the consequence of basic proportionality theorem? That is what we are seeing now. Some results which follow from the basic proportionality theorem. So, now take this result AD by DB equal to AE by EC. Now, add 1 on both sides. Then what will I get? AD plus DB by DB is equal to AE plus EC by EC. We know that AD plus DB is AB and AE plus EC is AC. So substituting, you get AD by DB is equal to AC by AC. So this is a result which follows from the basic proportionality theorem. Now, if this ratio is true, if A by B equal to C by D, then B by A equal to D by C. So using that, I have just inverted the ratios. So DB by AD is equal to EC by AE. And then I have added 1. Then what do you get? You get AB by AD is equal to AC by AE. So that is also a consequence of basic proportionality theorem. AB by AD equal to AC by AE. So these three results we must know, understand the logic behind it, so that it will help us to solve problems. But even before we complete, we should also see what is the converse of the basic proportionality theorem. Okay. Let us recall what is the basic proportionality theorem. We know that in a triangle ABC, if DE is parallel to BC, if DE is parallel to BC, then AD by BD is equal to AE by AC. Okay, this is the theorem called as basic proportionality theorem. Now, what will be the converse of this statement? That is what we are going to see now. So, let us draw a triangle ABC. D and E are points such that these two sides are divided in the same ratio. So, what is given? AD by BD equal to AE by EC. What is it you have to prove? DE is parallel to BC. So, if AD by BD equal to AE by AC, you have to prove DE is parallel to BC. This is the converse of the basic proportionality theorem. So, that is, the statement goes like this. Let ABC be a triangle. D and E are points on the sides AB and AC such that AD by BD equal to AE by AC. Then DE is parallel to the third side, which is BC. Okay. So that is the statement which I have written in a concise form. This is given and this is to be proved. Now we are going to prove by method of contradiction. So let us assume, let DE be not parallel to BC. Let us assume it is not parallel to BC. If DE is not parallel to BC, then there should be a point, some other point F, right? It should be parallel to BC. So let DF be parallel to BC. See, if DE is not parallel, then through D I can draw, I should be able to draw another line which is parallel to BC. I am calling that as DF. Now, if DF is parallel, this is what I am calling as DF. Okay. Now, if DF is parallel to BC, then by BPT, then by basic proportionality theorem, now if DF is parallel, then I can apply the basic proportionality theorem. What will I get? AD by BD is equal to AF by FC. Okay. Now, what is given? AD by BD is AE by EC. We have got AD by BD equal to AF by FC. So, what is given? I will mark as 1. What we have obtained will mark as 2. Okay. So, from 1 and 2, What do you observe? The left hand sides are one and the same. This is also AD by BD. This is also AD by BD. Therefore, the right hand sides should also be the same. So, you will get AE by EC is equal to AF by FC. Now, add 1. Now, adding 1, you get AE by EC plus 1 is equal to AF by FC plus 1. That is, AE plus EC is what? AC. AC by EC. What is AF by plus FC? That is also AC by FC. Now again the numerators are same, which therefore EC must be equal to FC. Therefore E and F are must be the same point, must coincide. See, if from these two we get AC equal to FC, when will EC be equal to FC? Only if it is possible if F coincides with E, or rather E and F represent the same point. Okay, so now therefore what we have got a contradiction. Therefore what we assumed is not correct. What did we assume? DE is not parallel to BC. Therefore DE is parallel to BC. Is it clear? Therefore DE is parallel to BC. Now this is what we are applying here also. See, for example, look at the first sum. AD is x, BD is x minus 2, AE is x plus 2, EC is x minus 1. Okay. Now, what is missing in the problem is DE is parallel to BC. That they should have given. DE is parallel to BC. If DE is parallel to BC, then when will it happen? X by x minus 2. This is an application of the basic proportionality theorem. X plus 2 by x minus 1. This implies x square minus x equal to x square minus 4. Minus x is minus 4, therefore x is equal to 4. So you can solve for x using basic proportionality theorem. If x is 4, this will be what? If x is 4, this is 2. This will be 6. This is 3. 4 by 2 is 2, 6 by 3 is also 2. So you can also verify whether the solution that you got as x is correct. It is correct because the ratios are one and the same. Are you able to follow this? Now look at this problem. You are given a figure, you are given a triangle PQR and XY is parallel to QR. PQ by XQ is given to be 7 by 3. Okay, and PR is given to be 6.3 centimeter. You have to find YR. So PR is given, you have to find YR. We know that by consequence of BPT, PQ by XQ, PQ by XQ is same as PR by YR. Therefore, now what is PQ by XQ? 7 by 3. 7 by 3 is equal to PR is 6.3. YR is what we need to find. We'll keep it as X. Let YR be X. Okay. Therefore, 7x is equal to 6.3 into 3, which is 18.9. This is 7x. So x is equal to 18.9 by 7. So this will be 2 point what? 14, 4.9, 2.7. So x will be 2.7. Are you able to follow? Are you able to understand? Is it clear? Okay. Now P and Q are points on the sides DE and DF of a triangle DEF such that DP equal to 5, DQ equal to 6 centimeter, DE equal to 15. So if DE, so you are given DE is 15, but you know DP is 5. Therefore, your PE will be 15 minus 5, which is 10. This is what we have entered here. This whole thing is 15. Okay, this is 5. Therefore, 15 minus 5. So, this portion must be 10. Similarly, you are given what? DQ equal to 6. DQ equal to 6. And and QF is 18. QF, this side is 18. The question is PQ parallel to EF? When will PQ be parallel to EF? Only when these two ratios are one and the same. If PQ is parallel to EF, then what ratios should be one and the same? Then DP by PE must be equal to DQ by QF. Okay, verify. Let us verify. What is DP by PE? 5 by 10 equal to DQ is 6 by 18. So this is half, right? Whereas this is 1 by 3. 6 by 18. You are given QF is 18 and DQ is 6. So 6 by 18, whereas this is 5 by 10. Not true. Right? Therefore, PQ is not parallel to a converse of BPT. It is not parallel to EF. Okay. So, if these two ratios are one and the same only, PQ will be parallel to EF. That is the converse of basic proportionality theorem which we proved today. Now, we see that this ratio is half while that ratio is 1 by 3, which means PQ is not parallel to EF. Is it clear how to apply these results and how to solve problems? Now, look at this. Now, in the adjoining figure, LM is parallel to CB. So, what is given? LM is parallel to BC. And LN, so LM is parallel to BC. Now, LN is parallel to CD. LN is parallel to CD. That is what is given. Okay. Then you have to prove this result. Okay. Now, if this is parallel to this, consider triangle ABC. Let us consider triangle ABC. ABC. Now, this is parallel to this. Therefore, these two sides will be divided in the same ratio, right? So, by converse of BPT, what will you get? AL by LC. AL by LC will be same as AM by MB. AM by MB is same as AL by LC. I have considered which triangle? Triangle ABC. Now consider triangle, this triangle ADC. So in this triangle, why are we applying this? Because LM is parallel to BC. Therefore, AL by LC is equal to AM by MB. Now you are considering the triangle ADC. Now here in this triangle, what do you observe? LN is parallel to DC. So by converse of BPT, what does it follow? AL by LC is equal to AL by LC is equal to AN by ND. So I have looked at this triangle. AL by LC is AN by ND. If I look at the triangle ABC, AL by LC is AM by MB. Both these are by virtue of the fact that NL is parallel to DC and LM is parallel to CB. And we are applying the converse of BPT. Now combining results 1 and 2. From results from 1 and 2. Okay. From 1 and 2, you can see the left hand sides are one and the same. This is also AL by LC. This is also AL by LC. AM by MB is equal to AN by ND. This is what we wanted to prove. Are you able to follow how to apply the converse of basic proportionality theorem to solve problems? Okay. So we saw a few examples. We will see even in greater detail in the next video. Okay. Please go through the basic proportionality theorem, go through the proof of the converse, and let us start solving even tougher problems. These are very basic problems which follows directly from the theorem. So first you get a good understanding of these problems, then we will do even difficult problems. So until we meet next time, it's goodbye, and I hope you are enjoying these sessions of Maths with RP. Continue to subscribe, continue to learn, and let's learn together, and let us see how we can crack the board exam and get really maybe full marks in the board exam with all the efforts that both of us put together. Until we meet next time, it's goodbye.